In this section 2.4, we're going to begin our conversation about slope, and we're going to look at how to calculate slope and what it means. And then we're going to continue our conversation later on and look at slope in a variety of different contexts and different situations and talk about what it describes about the graph of a situation. Okay? So, when we think about slope, I really want you to think about slope as a rate of change. I mean, that's really the most fundamental definition of slope. It's a way to measure how fast your y values are changing compared to how fast your x values are changing. And remember, rates are things that measure things like speed, like how fast things change. So slope as a rate of change is going to measure all sorts of different kinds of variables that we might be interested in graphing. Today, we're going to look at it just numerically. So how do we actually get that measurement for what slope is? Okay, so let's take a look at these graphs down here. And which of these graphs do you think shows y changing the fastest? Is it the first graph that's going from left to right in a sort of upward direction? Is it the second graph that's going from left to right in a downward direction? Or is it the last one, which is a relatively almost flat graph? It's definitely the flattest of the three graphs. So if you think about this, the one that shows y changing the fastest is the second one because it has the steepest line. We can see that the y values, if we look at, I don't know, a width about this big, the y values changed a whole lot. If we look at a width, that same width, on a different graph, you can see those y values didn't change as much. And the same thing is true on the last graph. If we look at that same width in the x direction, you can see your y values hardly changed at all in that almost flat graph. So the second graph is really showing us y changing the fastest. You can tell that also because it's the steepest of the three graphs. So it has the biggest slope. But it also has a slightly different slope because, as you can see, the first and the last are rising from left to right, and the middle one is falling from left to right. So we're going to use a positive and negative value to identify whether it's rising or falling from left to right. Alright, so now let's talk about how we measure slope. Slope is defined as the change in the y values divided by the change in the x values. And in mathematics and in science, a lot of times we use this little triangle to indicate change. So we say the change in y over the change in x. And this little triangle here is the Greek letter delta. And in mathematics and all sorts of different things, delta means change. So it's a nice little shorthand way for us to say the change in y divided by the change in x. It's a ratio. It compares how fast y is changing to how fast x is changing. So if we were to look at 2 points on the line of this graph that we see, a point here and a point here, we can see that the change in the y values is represented by this little vertical component, and the change in the x values is represented by this little horizontal component. The slope would be defined as this y value divided by that x value. So let's do this a little bit numerically. Let's find the slope of this line. Now the best way to do this is to try to find a couple of points that are really nice points on the line. So for example, this looks like a pretty nice point. I can tell exactly where it's crossing, and how about right here? That looks like a pretty nice point as well. And so what we're going to do is draw a little triangle that shows the horizontal and vertical changes between these 2 points. Okay? So we can see here my y values are different by 2 units, and my x values are different by 4 units if I count over 1, 2, 3, 4. So that means that the change in y is equal to 2. The change in x is equal to 4. And if I look at the ratio of those two things, the change in y divided by the change in x, I get 2 over 4. And now you realize, of course, oh, we might be able to simplify that to get 1/2. So we could say that the slope of this line is 1/2. So slopes that are less than 1 are generally relatively flat. They're not super flat, they're not exactly flat, they're just not that steep. And slopes that are greater than 1 generally tend to be a little bit steeper. The higher the value, the steeper the line. The lower the value, the flatter the line. Alright, let's talk about a formula for slope. Again, a similar type of diagram here, and what we want to do is create that same little triangle that we were looking at before, so we compare how much x changes to how much y changes, right? If you look over here and look at these coordinates the way that I've described them, this coordinate is x1, y1. That means I'm talking about the x coordinate of the first point and the y coordinate of the first point. This is representing the x coordinate of the second point and the y coordinate of the second point. That means if you were to drop down onto this axis, this x value right here would be represented by x sub 1. And we're doing this in general because we want this point to be able to represent any x value at all. So we're just talking about the x value of the first point. That means this y value right here would be y sub 1. It's the y value of that first point. And in a similar way, this x value along this x-axis would be x sub 2, and this y value along the y-axis would be y sub 2. So, if we wanted to find the change in the y values, how would we do that? In other words, we want to figure out what is the length of this little line right here. How much did my y values change? Now think about it for a second. If this point up here on the y-axis, if that point were like 10, and this point right here were like 6, how much did my y's change? Well, they changed 4 units. I know they changed 4 units because 10 minus 6 is equal to 4. So that's how we can figure out what the change in the y values is. We're going to subtract y2 minus y1. We're going to subtract those two y values. And in a similar way, we're going to do the same thing with the x values. Let's say this x value was 2 and this x value was 9. How much did my x values change? Well, they changed by 7 because 9 minus 2 is equal to 7. So that means the change in my x's is given by subtracting my x coordinates, x2 minus x1. And remember, we want the change in y over the change in x, so we're just going to divide those two differences. That gives us our slope formula, which is represented right here. So maybe even write that down and put a circle around it. M is going to be the letter that we always use to represent slope. So our formula for slope is y2 minus y1 divided by x2 minus x1. So let's do an example. Let's find the slope of the line that passes through the points 4, 3 and negative 2, 1. Now the first thing that I like to do with any problem like this is take my points and label them and determine which one we want to be x1, y1 and which one we want to be x2, y2. And it really doesn't matter which you choose. So I'm going to label this. 4 is my x coordinate of the first point, 3 is the y coordinate of the first point. That means negative 2 will be the x coordinate of the second point, and positive 1 will be the y coordinate of the second point. And let's recall my formula is y2 minus y1 divided by x2 minus x1. So plugging in those values, y2 is 1. And we're going to subtract from that y1, which is 3. Now let's divide. x2 is negative 2, and we're going to subtract from that x1, which is 4. So 1 minus 3 is negative 2, and negative 2 minus 4 is negative 6. Now we should check to see if we can reduce. Okay, we always want to check and see if we can reduce our slope. So the first thing we're going to look at is a negative divided by a negative is a positive. So this slope is going to be positive. And then 2 over 6 reduces to 1/3. So the slope of this line is going to be 1/3. Now you should also check your work with a graph by plotting the points. So for example, the point 43 would be, and I'm just drawing a really quick sketch here, right there, and negative 2, 1 would be right there. And you want to make sure that that same slope is represented when you look at the horizontal change and the vertical change like we did earlier. All right, let's talk about some different types of slope. Lines can have any of these 4 types of slope. They can have zero slope, the slope could be negative, they could have what we call no slope, or they could have positive slope. So lines that rise from left to right are said to have positive slope. And we define it that way because we want to be able to tell the difference between something that's rising from left to right and something that's falling from left to right. So we just kind of determine this is how it's going to be. If it's rising, positive slope. If it's falling, the slope is negative. All right, so what if it's not doing either one of those things? If the line is horizontal, we say that it has zero slope. And there's a very good reason for this. If you look at 2 points along the line, how much is the y value changing? The y value isn't changing at all. There's no difference in it. So even though the x value might be changing, I don't know, maybe that's changing by 2 units or something, 0 divided by 2 is 0. So that line has zero slope. For the other line, we had 2 points. If we take 2 points along the line and we look at that same thing, we can see that there is a change in the y value. Let's say that vertical distance was 3. But the problem here is there is no change in the x value. My x's aren't changing at all, so the difference between them is 0. And we can't divide by 0. So since we can't divide by 0, we say that this line has no slope. Another way we represent that sometimes is we'll say that the slope is undefined. That's another way of saying exactly the same thing. No slope, undefined slope, all represent the slope of a vertical line. Okay? So let's do another example. Let's find the slope of this line using 2 different methods. Well, the first method I'm going to choose is to use the formula y2 minus y1 over x2 minus x1. And just visually inspecting it, I can see that it's falling from left to right, so I know that the slope has to be negative, and that's a great little check to make sure that my arithmetic is correct when I plug something into the formula. I want to make sure that my final answer is in fact negative. So in order to use this formula, I have to find 2 points on the line. So it looks like here is a nice point. I could find its coordinate. It looks like I went to the left 3 and up 2. So its coordinate is negative 3, 2. Let's see. Oh, here's another point that I can probably calculate. That went to the left 2 and down 1. So that would be negative 2, negative 1. So I'll let this one be x1, y1. I'll let this one be x2, y2. Plugging those into my formula, we would have negative 1 minus 2. So the y2 is negative 1, y1 is 2, so we're subtracting those. x2 is negative 2, but I'm subtracting x1, which is negative 3. So be really careful with your arithmetic here. If I rewrote this, on the bottom I'd have negative 2 plus 3, because when we subtract a negative, that becomes addition, or becomes positive. So negative 1 minus 2 is negative 3. And on the bottom, negative 2 plus 3 is 1. So if I simplify that, I can just say my slope is negative 3. Perfect. So we had to find this two different ways. So I did it one way using the slope formula. The other way we can do it is by looking at those change in the y values compared to the change in the x values. Now I can see that my y values are 3 units apart here. I can see that my x values are 1 unit apart. So the change in y divided by the change in x is also 3 over 1. But here I have to use that fact that I know that a line that falls from left to right is negative to include the fact that this slope is negative. The other way you could think about it is I'm going down 3 units. So the slope has to be negative. All right? One of the ways that we talk about this little triangle is the rise and the run. So the rise tells me how much I'm going up or down between 2 points. The run tells me how far I'm going over between 2 points. And then we just divide them. So another way we talk about the change in y over the change in x is the rise over the run. Alright, so that's it, but I'd like you to write down some of the key points from this lesson and have those in a nice part of your summary. So the key points about slope is that slope is rate of change. Slope can be represented as rise over run. The formula for slope is y2 minus y1 over x2 minus x1. But all that means is we're looking for the change in y divided by the change in x, which we can also represent with our deltas, delta y over delta x. Okay? So I want you to write down these key points, use them as you're practicing the homework problems today.